Hello, I welcome you all to EDUKEM channel. In this video lecture, we are going to discuss about the next part of structure of atom. Those are quantum numbers and shape of SPDF orbitals. So this picture shows about the different spin of electron. It can be clockwise or anti-clockwise. Okay. So in the further slide, we'll discuss about all these quantum numbers. And so without a doubt, let's start. The first quantum number is principal quantum number. The principal quantum number represent with a small n. The principal quantum number. It determines the energy of electron in an orbit where the electron is present. So this principal quantum number determines the energy. So how do you know which principal quantum number determines the energy? You take the Bohr concept is equal to minus 13.6 z square upon n square. Okay. Now what is n? N is the principal quantum number or shell number. So now you see when you increase the n value, 1 by n is going to decrease, and negative sign of a decreasing value is always increasing. So we can say that if n is increasing, then energy is also increasing. So this n value determines the energy. Now there is a bigger question: what are these quantum numbers? So basically the quantum numbers are the locations. Okay, for an example, let's suppose we are talking about this nucleus is there. So around the nucleus some electron is revolving. So as we can see that we can know what is the energy of that electron present. In generally you can think of some cases like, so, your home is some place, your home has some address, right? Like India is divided into different states, and states are divided into different districts are divided into different blocks and towns and so on. So this principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number, these four quantum number represent the location of the electron. So now second point tells about the maximum number of electron in an orbit given by 2n square. Remember, if you'll put the value of n, what are n? N is equal to 1, 2, 3, 4 and so on. So we'll put the value, you will get the number of electrons. For an example, if you'll put n equal to 1, so what is the 2n square? If n is equal to 1, then the value will be 2. So the first orbit 2 electrons are present. Third point, it determines the average distance between electron and size of nucleus. Yes, see, if this is our nucleus, if this is our radius, okay. So can we determine the radius? Yes, we can determine the radius. Radius can be calculated from the Bohr radius. Next one, it gives the information of orbit KLMN. As we know that if n is equal to 1, that is K, 2, L, 3, M, 4, N. The value of energy increases with increase in value of n. As I already explained in above, if n is increasing, so energy is also increasing. It represents the major energy shell from which the electron belongs. So we can say that when we go away from the nucleus, we will see that n is increasing, hence energy is also increasing. So the next quantum number is azimuthal quantum number. It represents with a small l. So it determines the subshell or sub-energy level to which the electron belongs. Basically, it tells about the different partition of the orbit. That means if this is the nucleus and this is an orbit, then inside the orbit there are various partitions or blocks are present. Okay, so those blocks are called sub-energy levels or subshells. It tells about the shape of subshell. So basically it tells about how the subshells are. Next one is it expresses the energy of subshell. So the subshells are like S, P, D, F, and you have to remember. So S, P, D, F, if you arrange the subshell according to their energy, so F has the highest energy and S is the lowest energy. So S, P, D, F are the subshells. Next one, the value of L is integral value of n equal to 0, 1, 2, 3, 4 and so on. So basically value of L is determine the value of n. So here you can see this table. If value of L is 0, that means we can say that is S subshell. Value of L is 1, we will say that is P subshell. Value of L is 2, we will say that is D, 3 is F. Further, there are values, but we won't have to consider those values. Okay. So you have to remember this S, P, D, F throughout your 11th and 12th class. And we'll talk about the shape of orbital. S subshell is spherical in nature, P subshell dumbbell in nature, D is double dumbbell or cover leaves, and F is complex. We don't have to consider the shape of F. Next one is, it tells about the orbital angular momentum. As I already told you, any particle is revolving. That means it must have some momentum. So the orbital angular momentum is given by h upon 2 pi root over L into L plus 1. If you know the value of L, just put the value of L, you will get the answer. What is the orbital angular momentum? The number of electron in the subshell is given by L into L minus 1. You remember the formula. So next quantum number is magnetic quantum number. Magnetic quantum number is represented with the small m. It tells about the orientation subshell. The value of m varies from minus L to plus L. That means a value of m is again depend on the value of L, including 0. Okay, you have to include 0 also. Next one, for a given value of n, the total number of m is equal to n square. This is n square. So n square. So if you know the value of n, you can put the value of n and you will get the value of m. For a given value of L, the total value of m is equal to 2L plus 1. Again, this you know the value. If you know the value of L, you can find out the value of m by formula 2L plus 1. Degenerate orbitals having same energy. So there are degenerate orbitals. So you remember this further in the next slides. We'll discuss these degenerate orbitals. The meaning is they have same energy. For an example, for P subshell, there are 3 values of P. So for an example, you take if L is equal to 1. So this we know that is P, right? If L is equal to 1, that is P. So for L is equal to 1, what are the value of M? M can be minus L to plus L. That means including 0. So the value of M will be minus 1, 0 and plus 1. These 3 values are called degenerate and they have same energy. So minus 1 represent one subshell, that is Px, 0 represent Py, plus represent Pz. So here it is given Px, Py and Pz. The number of degenerate orbital for S is equal to 0. That means there are no degenerate orbital for S subshell. So the next quantum number is spin quantum number, represent with small s. The value of S that can be plus half or minus half. So this is plus half and minus half represent your clockwise and anti-clockwise rotation. Okay, so you can see that this picture tells about the one is the clockwise, another is the anti-clockwise rotation. So the values is given depending upon their rotation. So what is the main picture you see? So you can think of a solar system. Okay, so solar system is like, structure of atom is nothing but the solar system. So this is sun. So sun has different orbit. Okay, if this is our earth, so earth is revolving around the sun as well as it is rotating around itself. So same thing is happening inside the atom. So this is nucleus, electrons are there. So electrons are revolving around themselves as well as it is rotating around the nucleus. So the same concept is applied here. Next point is spin may clockwise or anti-clockwise, as we show that. Spin angular momentum is given by, this is the value of spin angular momentum, h by 2 pi square root s into s plus 1. So if you know the value of s, you will put the value, you will get the spin angular momentum. So next we'll talk about the structure of subshells. So what are those subshells? Subshells are S, P, D and F. So you remember these 4 subshells. So S represent your first subshell, that is for S, the shape of S is spherical. S represent your spherical. So this is a spherical, this represent your spherical S subshell. For S, there is L is equal to 0. Okay. Next one is P subshell. As I already told you, P subshell has 3 degenerate orbitals. Okay. So that is Px, Py and Pz. So how that Px, Py, Pz are aligned, as these orbitals are 3D shape. So Px means this is called lobes. You remember, this is called lobes. So the two lobes of Px represent on the x-axis, and the shape of P is nothing but your dumbbell. So can you see that this is a dumbbell shape? Yes, this is a dumbbell shape. These are lobes. So Px means the lobes are present on the x-axis. Py means the lobes are present on the y-axis. Pz means the lobes are present on the z-axis. Okay, you can think of values like -1, 0 and +1. Here is also another picture is given. This is also Px, this is Py and Pz. So next we'll talk about the D subshell. So D subshell has 5 degenerate orbitals. How it is 5? See, for D, what is the value of L? For D, value of L is 2. So as we know that for L is equal to 2, what are the value of M? M can be minus L to plus L. So this is -2, -1, 0, +1 and +2. So these all are known as degenerate orbitals. And how many degenerate orbitals we got? 1, 2, 3, 4, 5. So those 5 degenerate orbitals are dxz, dyz, dxy, dx square minus y square, and dz square. Now dxz means the lobes are present on the x and z axis. So can you see that these two are x and z? Yes. Dyz means the lobes are present on the z and y axis. Dxy means the lobes are present on the x and y axis. Dx square minus y square means the lobes are present on the axis. Here those lobes are present on the plane, but here the lobes are present on the axis. Dz square means is kind of lobes are there, and there is a ring which cover the center. Okay, there is a ring cover the center. Now quantum numbers, will derive the value of quantum numbers from 1, 2 and 3. Okay, so we'll find out all those values when the value of n is equal to 1, 2 and 3. So n cannot be 0. The value of n will start from 1, right? If n is equal to 1, what is the value of L? L, that is 0. What is the value of M? M is 0. What is the value of S? S can be plus half or minus half. Okay, so I'm writing plus half, minus half. Next one, if n is equal to 2, L will start from 0, after that 1. Okay, so as we know that depend upon L is n minus 1, it will go n minus 1. So L is equal to 0 and 1. Okay, if L is equal to 0, what is the value of M? M is 0. S again, it will always have plus or minus half. So this is plus half and minus half. If L is equal to 1, what are the value of M? M will depend upon minus L to plus L. So if L is equal to 1, it will have -1 value, 0 value or +1 value. So for -1 we'll have plus or minus half. For 0 we'll have plus or minus half. For +1 we'll have plus or minus half. So now if the value of n is equal to 3, so what is the value of L? L can be 0, L can be 1, L can be 2. So for 0, what is the value of M? M is 0. What is the value of S? S is again plus half or minus half. For 1, what is the value of L? L will go from -1, 0 and +1. So for -1, it will have plus or minus half. For 0, it will have plus half or minus half. +1, it will have plus half and minus half. For 2, M will be -2, -1, 0, +1 and +2. So each individual will have plus half, minus half. So how many plus half, minus half? 5. So plus half, minus half, plus half, minus half, plus half, minus half, plus half, minus half, and here it will be plus half and minus half. So 5. So each plus half and minus half represent your electron. So how many total number of electrons are there? So if you'll calculate total number of electron is 28 electron. So as we know that a basic formula in our lower class, that is concept of 2818. So this is KLM. So if you'll add it, so how much you'll get? 28. Okay, so that is matching with 28. Thank you for watching this video. Please like and subscribe EDUKEM channel and share with your friends. So if you want to connect with me with my social media account, my Instagram and Twitter handles are this. So till then, signing off.